Good morning, everyone. In this video, I will be talking about system design. So, during the analysis, so we have seen in the previous videos, during the analysis, the focus is mostly on what needs to be done. Okay, we have not given much focus on how it is done. Okay, and how it is done is the part which we will be looking as part of system design. Okay. So during design, developers actually make decisions about how the problem will be actually solved. Okay. First, it will be looked at high level, and then we will look at it in more detail. Okay. So that's how it also has two stages. Okay. One is the system design, and the other one is the class design. So during the system design, we actually devise high level strategy. Okay. So more or less we'll be developing this system architecture. Okay. Which will be used for solving the problem and building a solution. Okay. So the system architecture is basically used for that one. The system architecture actually determines the organization of the system into subsystems. So a complete system which you are trying to develop may have several subsystems, isn't it? And how all these subsystems are actually organized is the one which is actually taken care uh, as part of this sort of system architecture. So the system architecture also provides the context for the detailed decisions, okay, which will be taken in the latter stages of object-oriented software development. Okay. So in that sense, system architecture is crucial and system design is a very important stage. Okay. So during the system design stage, the developer has to take several decisions. Okay. Okay, let us look at each one of them. Okay, so we'll be discussing each and every one of these things in detail in the coming videos. Okay, but I will try to quickly summarize the things. Okay, so that we will have some sort of index. Okay, for the rest of the videos. Okay, for the coming at least 5-6 videos, which will be coming after this video. So the first design decision which has to be taken is we have to estimate the system performance. We need to have a rough estimate of the complete system performance. Say, for example, if we think in terms of the same ATM use case which we have talked during the application analysis, okay, how many requests will be there in the ATM system? So there will be a sequential invocation of the ATM, okay, but then there will be different ATMs across the city or across a wide area. So how much load will be actually coming with all these ATM systems together? Okay, that is your actual system which is being built. You need to have an estimate about that one. So approximately if there are 40 different ATMs are there of a particular bank, okay, there will be approximately 40 concurrent requests, okay, at peak time. So some sort of estimate. That's about this system estimation, estimating the system performance. Once you have estimated the performance, you need to make a reuse plan. Okay, it is not always required that you build a system completely from scratch. Use existing things. At the same time, in your project, you actually create the things that can be reused later. Something like libraries, frameworks, patterns, etc. We'll be discussing all of them in detail. Okay, as I mentioned in the coming videos. Then we have to organize the whole system into subsystems. Okay, even if you take the ATM case, you have this ATM, you have the bank, and then you have the consortium. There are different subsystems are existing. Okay, each is to be designed properly. Then we have to identify the concurrence inherent within the system. So this process basically deals with this step basically deals with identification of objects which are active concurrently. Okay, so that means they are working together. Okay, so they are alive at the same time. Okay, they are active and which have mutually exclusive activity. So they may not depend on other objects. So we have to identify these things. Okay. Then we have to identify the subsystems to the hardware. Okay, so for example, once you identify the subsystems, you should be able to allocate these subsystems to particular hardware. Okay, so how big a subsystem will be, how much hardware is required. Okay, so these are the things which are which basically come in this step of system design. Then we should also make decisions about managing the data store. Say, for example, where you will save the data, whether it will be in file systems, whether it is in relational database systems, etc. So these are the things which are to be these decisions are to be taken. Then we must also handle global resources in the system design. Okay, so global resource is something like the physical units which are existing. The ATMs are existing everywhere. And then, like say for example, if you are trying to enter something into the system, what is the space which you will be using? Okay, so the space in terms of your design, you have those numbers and then like the enter and everything. Okay, that space, that is the one which you will be using. And also like the other global resources include something like logical namespaces, how you will actually use them. Okay, how you will basically have your class names. Okay, even if there are across different systems and different subsystems, how you will organize them. So these are the decisions which are to be taken care. Okay, so during the system design. And then like we should also think about this, we have to choose this software control strategy. Okay, there will be different controls like external control, how the system is interacting with external things, internal control flow. Okay, such as it can be procedure driven or it can be event driven. What these things we'll discuss in detail. Okay, then we should also have design decisions for handling boundary conditions. Okay, how the system will be initialized, how the system actually terminates. Okay, what would happen if there is a failure? So all these decisions are to be taken care of. Okay, and then like we also need to have this sort of we need to set these trade-off priorities. Okay, say for example, if there is an urgent need for the developing the system, which of the subsystems or which parts of the system you will develop immediately. Okay, so which will have higher priority. So these things also like we have to take care of. Then of course like we have to select an architectural style. So how the system will eventually be developed, whether it will be an interactive system, it will have some sort of interfaces using which like you can actually interact with the system, something like the ATM itself. Okay, so or like a web-based application, or like whether it is a real-time system. Okay, so the decisions are taken right away. Okay, something based on sensors or something like that. Okay, so we need to have this sort of architectural styles also have to be decided. Okay, so that means like by the time like you have finished the system design, so all these steps are basically taken care of. So all these design decisions are taken care of. Regarding the references are concerned, okay, so now we are in chapter 14 of this object modeling and design with UML book. Okay, thank you very much for your attention.